Okay, here we are on the second page. The camera ran out of storage space and I just kept on yakking, so I did almost this whole page. Oh well, the results are that it goes from 2, that's the first term, to -2 to 10 to 70 to 46, 90. If you got that, great. If you didn't, here's why it is what it is. You plug in the previous term into this little formula to find the next term, because a sub n is just a sub n minus 1 squared minus 3 times a sub n minus 1. That's just the previous term. So I plug in 2 and I square it. I subtract 3 times 2. That gives me 4 minus 6. That's -2. So that's why that comes. Then I plug in -2, and I square it. And I subtract 3 times -2. Well, subtracting -6 is like adding 6. So 4 then plus 6 is 10. -2 squared is 4. Then I plug in 10 and I square that, and I subtract 3 times 10 and I get 70. And I plug in 70 and I square that. I get 4,900, and I subtract 3 times 70, which is 210. And that should give me 4690. All right? Same with this one. You just go carefully and methodically. You diagnose this as being arithmetic. You need to figure out how many n terms there are. How many steps does it take to go from -6 to 7986 when you're going up by 8s? So you write the formula out, and I know it equals that total, and I just solve backwards. I add 6 to both, I divide by 8, and I add 1. It's 1,000 steps. Then I have sigma notation from 1 to 1,000. There's my formula. So now when I do the formula for the sum, I take the first and last terms. That's the rainbow pair. When I add those up, it's 7980. If there's 1,000 numbers, there's 500 pairs. I just multiply them and I get that answer. For these guys, it's all about spotting the pattern and deciding if there's a limit. The top numbers are just the same as the n numbers. They're going up by 1, starting with 1, so that's n. The bottom numbers are going up by 1, but it's not starting at 1. It's starting at 9 units more than 1. That's just like a mini arithmetic sequence. So it's like this. Well, what's the limit? As n goes to infinity, this a sub n is going to approach or a sub, I guess that would be like infinity, but you don't really write it that way. But the limit is going to approach 1. This is like y, explain your reasoning. It's like Bobatin eats DC. This is an eats DC problem because this little invisible 1, the degrees are equal, so it's divide the coefficients, and that's a coefficient of 1 over 1. There you go. This next one, it's going up by 10. You're multiplying by 10 each time. I just have to make sure that I write that in the style that we do for a geometric sequence. So this one has no limit. It's going to infinity. All right? Last page. Got a good start on that. It is starting with 3. That's the first term. List the first 4 terms. Each term then is being added. I guess I could put a plus in there, and then a plus. It's really about what is this partial sum of 4 terms. And each time it's getting larger by 1.3, repeated multiplication. So then I just go to the summation of a finite. It stops at 20 terms. Finite geometric series. I plug in everything very carefully, and I get 1,890, point about 496. Okay. List the first 4 terms of this one and find the sum, if it exists. Okay. This one goes to infinity. Well, the first term is 100, and I'm multiplying by 0.8, so that's going to be 80. And then 0.8 times 80, if you do the math, it's going to be 64, and then 64 times 0.8. Don't get psyched out by it. Just use your calculator if you need to. Whoops. Times 0.8, and I'm going to be 51.2 plus ... I've been asked to find the sum. If it exists, it does, because these jumps are less than 1. If this was a jump of more than 1, like the one up above, if this went to infinity, it would have no finite sum. It'd be infinite. Okay, so what do? I say Sn is just that first term, 100, all over 1 minus r is 0.8. That's 100 divided by 0.2, and that's the same as 100 times, well, 0.2 is equal to 1/5. And the reciprocal of 1/5, flip it up and down, is 5. So I know this is 500. Okay, don't even need a calculator to do that one. If a golf ball is dropped from 100 centimeters onto the ground and it bounces to 85% each time of its height, we talked about one like this in class. Hopefully you're not going to get fooled by that as it goes down, and it's allowed to bounce forever. How far will it travel up and down? Well, start with thinking about the downs, and it's going to go down and then 85% down and 85% down if you want to do it that way. So 100 then, we're summing this from n equals 1 to infinity, and it's 100 times 0.85 to the n minus 1. That's the summation we're doing. The formula then is just going to be 100 this time divided by 1 minus 0.85. Okay, that'll give us all the downs. And then the ups are going to be twice that, so we can take this whole thing and we can multiply it by 2. But then remember, I never shot it up in the first place, so then I'll take away 100 for that first launch. So show all your work. If you don't get that perfectly and you've done the first half of it, you will of course get major credit. So what is that? Then that's going to be 100 then divided by 0.15. Okay, that's 666 repeating, and then times 2 is going to give me 1,333 and 1/3, and when I take away 100, it's 1,233 and 1/3. Okay, centimeters, all right. Okay, finally, in an arithmetic sequence, we have 10 terms. There's a total of 10 terms. The last term is 14. What is the sum? We know the sum is 50. Find the second term. Okay, this is sort of an honors level question. If you are thinking about honors level at some point in your career, you should be able to do one like this. What does it mean? Think about what your resources are. Well, we have a couple of formulas for arithmetic sequences. I can find any term by taking the first term and adding to that the common difference, and then n minus 1. I also know I can find the sum by taking the first term and adding the last term, and then having the number of terms over 2. Well, this is the one I can fill in everything but one. I know the sum is 50. I know that that's going to be equal to the first term, which I do not know, but I do know the last term is 14. And I do know that there are 10 terms, so that's going to be times 10 divided by 2. So that's going to be 5. If I divide both sides by 5, I can get 10 is equal to a sub 1 plus 14. Well, I know then a sub 1, when I take away 14 from both sides, negative 4 is my first term. All right, well now I can plug that into the top, and I can say that my nth term, which is my 10th term, is 14. That's going to be equal to my first term, minus 4, plus d, which I do not know, times 10 minus 1, which is 9. So 14 is going to be equal to minus 4 plus d times 9. I'm breaking this all down to make it understandable, I hope. Do not get psyched out. So then that is going to be add 4, that's 18, is equal to, I'm going to write 9 times d. So if I divide by 9, you'll see that d equals 2. That's my step. So if it's going up by 2 and I'm starting at negative 4 right there, I know that a sub 2 is going to be equal to negative 4 plus 2, and that's negative 2. There's your answer. All right? Could be something challenging like that, but it wouldn't be worth a ton of points. I'm sure you guys will do fine. Good luck.